Okay, we made it to long division. And before you get all freaked out, we can do hard things. You can do hard things no matter how long division went for you last year. I am confident that with practice, you can get it. So hang in there. It might take a lot of work, but I know that you can do it. So I'm going to go over two strategies. First, I will go over partial quotients, which is what I believe you did last year. And then I will talk about the more standard algorithm. Going forward, I'll split it into two videos again, but I want to do both of them in this video, so bear with me if it gets a little bit long. You can always come on and get help if you need it. So partial quotients is we're taking the number and we're going to sort of put it into groups that make sense to us. So if I have a problem like 495 divided by 6. Okay, well, I'm going to look for what groups I can put into there that go with 6. So like say I did 6 times 10. Okay, I know that's 60. So I can subtract 60 and then I get 435. Now, I'm not going to want to do just groups of 10 over and over because it could take a little while. Now, I could just keep subtracting groups of 10, but subtracting 60 and see how many times I can do it. But instead, let's look. If I have 435, I can think about my multiples of 6 and see if I can get close to 435. And when I say multiples of 6, I mean like, let me show you what I mean. So I have 6 times 1 is 6, 12, 18, 24, 30, 32. Oh my gosh, not 32. Woof. Hopefully you're like, Mrs. Morrison, what are you doing? 36, 42, 48. And I'm just really looking at these first two digits. And I'm saying, okay, look, 42 is close. So I know that's 6 times 7, but it's really 430. So it's really going to be 6 times 70. Because 6 times 70 is 420, which I know is very close to 435. So now I know that I can subtract 420 off of here, 5 and 1. So now I can say, okay, 15. I know how many times 6 goes into 15. That is 2 times, which is 12. So then I can subtract 12. Sorry, I ran out of space. And I get 3. And 6 doesn't go into 3 anymore. So how many total groups did I fit in? Well, I did 10 groups, then 70 groups, then 2 groups. So I can add those together, which tells me it went in 82 times with a remainder of 3. Okay, let me do another example with partial quotients. We're still just doing 3-digit divided by 1-digit. So divided by 3. And say, okay, 532. Well, I know that 3 times 100 is 300. So I'm going to start with that. If possible, start with like 10 or 100 or 1,000. So now I'm going to take and I'm going to subtract that over here. That's 2, 3, and 2. So I can't fit in another 100. But again, I can say, okay, 232. What multiple is close? So if I do 3 times, essentially I'm doing 3 times 10. So 30, 60, 90. It's almost like I'm counting by 30s. Or you can just count by 3s, 3, 6, 9, 12, 15, 18, 21, 240, 270. Okay. So which one of these is closest to 230 but smaller? Well, 210 is. So if I count again, 10, 20, 30, 40, 50, 60, 70, that is 3 times 70 equals 210. So I'm going to take away 210, see what I have left. I have 22 left. Well, if I just count by 3s regularly now, 3 times 7 is 21. If I subtract 21, I just have 1 left over. So again, how many groups did I pull out? Because I'm splitting 532 into 3 groups. And I'm just sort of doing it a little bit at a time. So first I put 100 in each group, then I put 70 in each group, then I put 7 in each group. So I ended up with 177, remainder 1. All right, that was partial products. Now I'm going to show you the quote-unquote standard division way. I'm going to actually use the same problems I used before. So if I have 495 divided by 6, okay, I'm not going to draw my line, but I'm going to look at, okay, how many times does 6 go into 4? Well, it doesn't. So I'm going to put an X up there. How many times does 6 go into 49? I can put my multiples of 6, 6, 12, 18, 24, 30, 36. I'm looking for one that's close, but not bigger. 54. Okay, so 48 is close, but not bigger. I can write that down here, and that was 8 times. So it went in 8 times. I really then multiplied 8 times 6 to put 48 down there. Now I'm going to subtract right here. 48 or 49 minus 48 is 1. Then I'm going to bring down my next digit, and I get 15. Then I'll go back up to the top of my steps. How many times does 6 go into 15? 1, 2 times. Multiply 2 times 6 is 12. Subtract 15 minus 12 is 3. I have nothing more to bring down, so then I am done, and that is my remainder. All right, I will do one more example, sort of the standard way. Now, with multiplication, they were all good methods. I will admit that I personally am a little bit biased towards the standard way with division. Not that I can't help you understand the partial products, but for whatever reason, this makes more sense to me, and I feel like I can really help you understand this, but I will help you with any of them. So, again, we have our first step is asking ourselves how many times. It's really HM, how McDonald's, sells burgers. How McDonald's sells burgers. How many times? Multiply, subtract, and bring it down. Sometimes you'll see that first step called divide. I think it makes more sense to ask ourselves how many times it goes in. So how many times does 3 go into 5? Well, if I look at my multiples, oh look, 6 is too big. It's bigger than 5. So this is only 1 time, which is what I put on the top. The top is where I write how many times. Then I multiply. Step 2. 1 times 3 is 3. Subtract. 5 minus 3 is 2. Bring down my next digit. And it might feel like I'm just pulling these and putting them and you don't even know where I'm going next. You'll get the hang of it. Okay, so just bear with me. If you need more practice, ask for it. Now we start all over at the top. How many times does 3 go into 23? Well, if I look at my multiples, or maybe you just count in your head, 3, 6, 9, 12, 15, 18, 21, 24. Oop, 24 is too big, so I'm at 21. That is 7 times. Now I multiply. 7 times 3 is 21. Subtract, because I multiplied, then I'm at subtract. 3 minus 1 is 2. Bring down the next digit, which is a 2. Back up to the top. How many times does 3 go into 22? 7 times again, because 7 times 3 is 21, which is very close. Subtract. I get 1. So my remainder is 1. If you still need more practice, no worries. Please ask. I will know whether you are actually doing your practice, because if you sorry, I lost my train of thought. If you do it on a calculator, you'll get a division instead, or you'll get a decimal instead of a remainder, and I will know that something is not quite right. So you will have remainders on some of these, and that will show me that you are understanding it correctly. So let me know if you need help.